back, and so now we want to start talking about igneous rocks, but before we can talk about them, we have to have a lot of definitions. So the way that we're going to classify igneous rocks is going to be based on two properties. So property number one is what are the minerals that are inside of that rock. So that's going to determine the identity of that rock. So if you go back to Bowen's reaction series, you'll see that, for example, a mafic rock is going to have in it, an example of a mafic rock would be basalt and gabbro. Whereas if you have an intermediate type rock, meaning it's got different minerals in it, well, then that's going to be andesite and diorite. So the minerals that are inside the rock are going to partially determine what type of rock it's going to be. The second property, though, that is going to determine the identity of the rock is going to be its texture. And by texture, we mean the size and the shape of the crystals that it's made of. And so there are two basic kinds of textures. You have extrusive textures and you have intrusive textures. So extrusive means outside and intrusive means inside. So that the primary extrusive textures are going to occur with materials that are either blown out of a volcano or they tend to accumulate at the surface of the earth, whereas the primary intrusive ones are going to be textures you're going to find in rocks that formed inside the earth. So let's look at the primary extrusive textures. You have pyroclastic. So pyroclastic materials are blown out of a volcano. So that meant that they have flown through the air. So that you could have welded fragments of lava that are stuck together, and you can also have actual chunks of rock that are flying through the air. So like volcanic breccia, for example. The second kind is vesicular. So that means that this kind of rock has holes in it that were caused by gas escaping. So an example of this would be scoria and then pumice. Okay, then a third type of extrusive texture is going to be glassy, and this material cooled off so quickly it did not even have a chance to make any crystals. So an example of this would be obsidian. Then you can have materials that are either very close to the surface or on the surface. They cooled off quickly so that they have very, very tiny crystals. They do have crystals, so if you were to look at them through a microscope, you could see the crystals in these rocks, but you can't see them with the naked eye, so we refer to this kind of texture as aphanitic. And so an example of this would be rhyolite or basalt, for example. All right, now let's look at those kinds of textures that you tend to have with rocks that form inside the earth. So one example is going to be phaneritic. Okay, that means it formed deep inside the earth and it had a long enough time period that those crystals grew to be very large. So that's going to be a phaneritic. Example of this is going to be granite. So when you look at a chunk of granite and you hold it to the light, you can see all those crystals in it. That's a phaneritic texture, and that tells you that that granite formed deep underground. That's where it cooled off. Now, on the other hand, let's look at porphyritic. So porphyritic is, for the most part, it's aphanitic. So when you look at this rock, you're not going to see any crystals. However, you're going to see a few large crystals embedded in this mass of non-crystals. So what this represents is that the rock originally began to form underground, and then those few crystals, which are called phenocysts, begin to form. Okay, but then for some reason that magma shot up to the surface. So it started to cool down here, and then it moved up to the surface before the rest of the crystals had a chance to crystallize. So that's why you end up with basically two textures, an aphanitic texture and then a few crystals thrown in. Then you have the third kind of texture, which is very rare, and this is called pegmatitic texture. And so what happens here is that you've got a magma chamber that also contains lots of water. And then that water allows very large crystals to form. So we're talking about crystals that could be up to 2 to 5 meters in length. So a meter is this big. So imagine a single crystal being like 2 meters, like 6 feet, all the way up to maybe 15 feet long. And so they have discovered, for example, some of these crystals. And so that it doesn't happen very often, but it happens if you have a magma chamber that contains lots of water. Okay, let's take a break, and when we come back, we will discuss the different kinds of igneous rocks.